Let us check the major minor axis and its lengths here. Here the line segment joining the foci F1 and F2, and this is the midpoint of this line segment. A line segment passing through O, which is perpendicular to this line segment. So the horizontal line segment passing through F1 and F2 is called major axis, and the vertical line segment passing through O is called minor axis. This is A and this is B, and this is C and this is D. Here A is a vertex and B is also a vertex. Now the distance from a vertex capital A to center A is A, and the distance from the center O to B is also A. And the distance from C to the center O is small b units, and the distance from O to D is also small b units. C to OB and O to D is also b units. Now the distance from focus F1 to O is C units, and the distance from O to F2 is also C units. From the above data we have the length of the major axis. This is major axis, AB is the major axis. So the length of this major axis is AO plus OB, that is equals to AO is A units, OB is also A units, A plus A equal to 2A. And the length of minor axis, so CD is the minor axis, C to O plus O to D, CO plus OD is equals to the minor axis. So it is B and this is also B. B plus B equals to 2B. Now the distance between F1 and F2. So distance between the two focus. F1 to O is C units, O to F2 is also C units. That is F1 O plus O F2 equals to C plus C equals to 2C. So this is major axis. A to O or O to B, the half of the major axis, are known as semi-major axis, and its length is A to O is A units or O to B is also A units. So semi-major axis length is A units, and CO and or OD are the semi-minor axis. Its lengths are CO is B units or OD is also B units. So semi-minor axis length is B. Now we construct a relation between semi-major axis. We construct a relation between semi-major axis, semi-minor axis, and the distance of the focus from the center of the ellipse. So here the semi-major axis is A, semi-minor axis is B, and distance of focus from the center of ellipse, distance from center to the focus of any focus of the ellipse is C units. So from this we conclude that this is the relation between A, B and C. Okay, now we are going to construct a relation between A, B and C. So let us use this diagram ellipse here. F1 and F2 are the focus. The line segment passing through F1 and F2 is the major axis, we know. This is the midpoint on major axis. Line segment passing through O is called minor axis. Let us choose PQ or any points on the ellipse. We have the distance from R to O is A units, and the distance from F1 to O is C units. O to F2 is also C units. Now joining the line Q to F1 and Q to F2, the distance from Q to O or O to downwards is B units. Let us choose PB one end of the major axis. Then by the definition of ellipse here, we have the distance from P to F1 plus distance from P to F2 is constant. So that is F1P plus F2P is equals to. So what is F1P here? F1P can be written as F1O plus OP. So F1O plus OP, which is equals to F1P, okay, and plus F2P here. Since F1P equals to F1O plus OP, so F1O is equals to C units, O2P is A units plus F2P. So to find F2P here, this is O2P is A units, O2F2 is C units, F2P is A minus C plus F2P is A minus C here. So plus C minus C cancelled, A plus A equals to 2A. So by assuming the point P, we have this. Now we assuming the Q is one end of the minor axis, then by the definition of ellipse, QF1 plus QF2 is constant. So F1Q plus F2Q is equals to, observe here F1Q is, here F1O is C units, OQ is B units. By Pythagorean formula we have, this is hypotenuse, so this is square root B square plus C square. Similarly, this is also hypotenuse here, also equals to square root B square plus C square by using Pythagorean formula. So which is equals to square root B square plus C square plus square root B square plus C square, that is equal to 2 square root B square plus C square. Here these 2 points P and Q both lies on ellipse, then by the definition of ellipse here, these distance should be equal, means same. So 2A is equals to or 2 square root B square plus C square equals to 2A. Here 2 cancelled out, A equals to square root B square plus C square. Now squaring on both sides, we have A square equals to B square plus C square. This is one relation, and from this C square is equals to A square minus B square. Now C equals to square root of A square minus B square. So these are the relations between A, B and C. Okay.